This is question 8 from November, paper 1, standard level from 2017. We have a function f of x, which is x squared minus x, and it crosses the x-axis at 0 at the origin and at the point 1, 0. So this is the point 1, 0. We're also then told the line L is the normal to the graph of f at p. So if you remember, the normal is the line that is perpendicular to the tangent. Okay, so if I actually think of the tangent here, there's the tangent, p. So it's nice straight line. Let me do that again. And I will do it with a ruler here somewhere. Straight line. Then red. Okay, so there is the tangent in red. And okay, so line L is the normal, and remembering that the normal cuts the tangent at right angles. We're also told that the line L intersects F at another point Q. First off, we have to show that f dash of 1 is equal to 1. Okay, so to go about that, we know f of x is equal to x squared minus x. So f dash means I need to differentiate it once. So differentiate, pull the 2 down, 2x, subtract 1 from the power, and then differentiate x, do the same thing, and I get 1. And then I need to evaluate this at x equals 1. So sub that in, and I get 1 out. Done. Okay, part B. I need to find the equation of L in this form. Okay, so in the form y equals ax plus b. So thinking back to our equation of straight lines, this is the gradient, and this is our y-intercept. So first off, this part A is relevant to part B. What we've actually done here for part A is we've worked out the gradient at P. So remembering, when we differentiate, we're actually finding the gradient at any point on the curve, okay? So we've differentiated f, we're finding the gradient at any point, and then we substituted 1 in, so we're finding the gradient at this point, okay, because that's at 1, 0. So the actual gradient then at this point, or at the tangent, so the gradient of the tangent is equal to positive 1. That means the gradient of the normal then is, well, you flip it, so 1 over 1, same thing, and then change the sign, negative 1. And we can also confirm that, if you remember the formula, the gradient of the tangent multiplied by the gradient of the normal always has to equal negative 1. So if I put these in, 1 times negative 1 is negative 1. Alright, so the gradient of the normal of line L, which is the normal, is negative 1. So let's put that in. Y equals negative 1x. And now I need to work out what the y-intercept is, and I need to do that by subbing in a value for x and y. And I know that my line L, the normal, goes through this point 1, 0. Okay, it goes exactly through here, so I'm going to sub this point in for x and y. So y is 0, x is 1, so it becomes negative 1. And then add 1 to both sides, so b equals 1. So my equation is y equals negative x plus 1. Okay, let me put a box around that. Okay, part C. Find the x-coordinate of Q. So I want to find this x-coordinate for Q. And I'm going to do that, okay? So I know that my line L, which is this equation, intersects my graph F, which is this equation at 2 points. So if it intersects, then these two equations can be solved simultaneously. So I've got my y equals negative x plus 1. I've got y equals x squared minus x. And if I put them equal to each other and solve simultaneously, and let me just scroll down a little. So I'm going to add x to both sides. So I get x squared. The x's are going to cancel. And then I'm going to subtract 1 from both sides. So I get x squared minus 1 equals 0. Now I'm solving for x. So I'm going to do that by factorizing this. It's the difference of two squares. So x and x. 1 times 1 is 1. Positive and negative. So that tells me that x is equal to negative 1 from this part, or x is equal to positive 1. And that makes sense because positive 1 refers to this point, this intercept. And then this is the other one at x equals negative 1. Okay, and for the last part, we have to find the area of the region enclosed by the graph of f and the line L. So that is this region. Okay, now I know that the x value here is 1. And I know that my x value for q, that's negative 1. So I've got my bounds already. It's between negative 1 and 1. This is the curve negative x plus 1. This curve is x squared minus x. And if I want to find the area between two curves, or a curve in a straight line, I need to integrate. And I'm going to do it between negative 1 and 1. And I need to do upper minus lower. So the upper is the straight line, which is negative x plus 1. And then I'm going to subtract off the lower, okay? Upper minus lower. And I'm going to put this in brackets because I don't want to make any silly mistakes with my positive and negatives. And I'm integrating with respect to x. So before I even do any integrations, I'm going to tidy this up. I'll expand the bracket. So this becomes minus x squared. And this becomes minus 1 times minus x is positive x. And that's good because the x's then are going to cancel. And I'm left with 1 minus x squared. Okay, now I just need to integrate this. And when I'm integrate 1 with respect to x, just becomes a 1x. And integrate negative x squared, so add 1 to the power. So it becomes 3, and divide by the new power, so over 3. So that's it integrated, and I now need to just put what my limits are going to be, then I'm going to substitute in. So I put my limits into this equation, so put 1 in first, and I'm going to use brackets here because I don't want to mess this up. 1 subtract 1 cubed, 1 cubed is just 1 over 3. And then I'm going to put negative 1 into it, so I've got negative 1 subtract negative 1 cubed over 3. Okay, so you put 1 in first, then you put negative 1 in, and we're going to subtract these two things off each other. Now 1 take away 1/3. That's the same as 3 over 3 take away 1/3, which is 2 over 3. And I'm subtracting off negative 1, subtract negative 1 cubed, because it's in brackets. cubing the whole thing, it's still negative 1. So I've got 2/3, subtract negative 1. This is going to become plus 1/3. So negative 1 plus 1/3, so that's negative 3/3, plus 1/3. Negative 3 plus 1 is, negative 3 plus 1 is negative 2. So I get negative 2/3. So you have to be very careful when you're doing this. So I've got that 2/3. I'm subtracting off, and we said that this is equal to negative 2/3. And the two negatives become a plus. Subtracting a negative is the same as adding a positive. Add your numerators. Do not add your denominators. And that is our area, 4/3. If you've got any questions on that, please ask. It's a nice little question, and you can see that the previous parts link in, okay? Part A is needed for part B, and part B is needed. Part B and part C are needed for part D. But it's definitely not too tricky, okay? So please look over it, and if you have any questions, just ask.